We've talked about ratios, and ratios, if you remember, look very much like fractions. It's a comparison of a couple of numbers to each other. But now let's talk about proportions. A proportion is a comparison of one ratio to another ratio, and it looks like one fraction equals another fraction. That's what a ratio looks like. Now don't confuse this with multiplying fractions. Look at the sign in the middle. It's equals, it's not multiplication. Therefore, you can never cross-reduce a ratio. You can only do that when you're multiplying fractions. Let's take a look at some ratios and how we use them, or some proportions with ratios. First example says 1 raisin is to 5 cornflakes as 8 raisins is to 40 cornflakes. Now, the words you're looking for are the words to and the words as, because these are separating. As is separating our two ratios. As is going to be equal, and to is going to be our dividing line between our two numbers in the ratio. So we will say, when we set it up, we'll say 1 raisin, and with ratios you always use labels, even if it's just the first initial. 1 raisin is to 5 cornflakes, as, there's your equal sign, 8 raisins is to 40 cornflakes. As you can see, it is one fraction equaling another fraction. And like we said with proportions, labels are very important. Look at example 2, and let's see if we can set this one up. 20 students is to 5 microscopes as 4 students is to 1 microscope. Well, the word to is important. The word as, that's our equal sign, and there's another 2 that's going to help us separate our ratios, or set up our ratios. Let's set the first one up. The first one is 20 students is to 5 microscopes. That's the relationship between students and microscopes. Ratios are set relationships, and that's what that one is. Now it says as, so here's where we get into the proportion part. One ratio equals another, right? As 4 students is to 1 microscope. Now, one thing you want to note about proportions is that, in the first ratio, my students are in the numerator. In the second ratio, I have to have the same label in that numerator. In other words, I have to put students in that numerator to match the students in the first numerator, even if they didn't give it to me that order in the problem. So the numerator labels have to match, the denominator labels have to match when we're setting up proportions. For example 3, let's see if we can tell if a proportion is what we call a true proportion or a false proportion. And what that means is we want to know if that first ratio is really equal to the second ratio. Is 8/6 really equal to 20/15? Well, you know that normally we would convert everything to have a common denominator and then see if the numerators matched. But there's another way with ratios that's easier. And what we do with ratios, or what we can do, is we can cross-multiply and set the products equal to each other. Now remember, this is not multiplication of fractions. With multiplication of fractions, we cross-reduce. With ratios and proportions, we cross-multiply. So let me show you how this works. First, I'll say 8 times 15. I could have said 20 times 6 first. It doesn't matter which way you go first. But I'll say 8 times 16 is equal to the other cross product, which is 6 times 20, or 20 times 6. The order doesn't really matter as long as you're cross-multiplying. Now, to say 8 times 16, I say 8 times 6, that's 8. Carry my 4. 8 plus 4 is 128. I think I did that right. And over here, I'm going to say 6 times 20, which is 120. And that does not look like, no wonder I did it wrong. 8 times 15, sorry. 8 times 15, now let's see what I've got. 8 times 15, 8 times 5 is 40. Carry my 4. 8 times 1 is 8 plus 4, 120. My second one, I did that right? 6 times 20, 120. They are equal. Since they are equal, this is what we call a true proportion. In other words, 8/6 really does equal 20/15. Let's check number 4, or example 4. We're going to cross-multiply again. We're going to say 5 times 7 equals 8 times 4. Or does it? Well, 5 times 7 is 35, and 8 times 4 is 32. So the two are definitely not equal. In other words, this is what we call a false proportion, since the two products do not equal. Okay, let's take a really fun one. Look at example 5. This looks suspiciously like a couple of complex fractions, doesn't it? But the same rules apply. It's really a proportion. It's one big, huge, complex fraction equals to another big, huge, complex fraction. So how do we solve proportions? Well, we cross-multiply to see if they're equal. Let's do this. We're going to set it up 2 2/5 times 1/4, and we're going to set that equal to the other product, which is going to be 2/3 times 10/9. Now, this is a complicated set of fractions. Let's just work on the left-hand side. Looks like I need to change that first mixed number to an improper fraction. I'll say 2 times the denominator of 5, which is 10, plus the numerator of 2. So I'll get 12/5 times 1/4. And I'm not going to do anything on the right-hand side yet. I'm still just working on the left. So I'll just copy it down. Now, over here on the right, on the left, I can cross-reduce, can't I? Remember, with fractions, I can cross-reduce these things to make my math easier. Both of these divide by 4. And now I want to multiply numerators. 3 times 1 is 3, and 5 times 1 is 5. And that would be equal to, over here on the right, look and see first, can you cross-reduce? Well, I kind of wish those numbers had been the opposite, because they would have cross-reduced nicely, but they don't this way. So I'm going to say 2 times 10, numerators, is 20, and 3 times 9, 27. Now, am I finished? I still can't tell if those fractions are equal or not. But look what I have. It's another proportion. It's a simpler proportion, but let's just do the whole thing over again. Let's start from there and say, if we want to see if they're equal, what do? We cross-multiply. We say 3 times 27 equals 5 times 20. Well, 3 times 7 would be 21. Carry my 2. 3 times 2 is 6 plus 2, 81. Over here on the right, 5 times 20, I know that one, is 100. It does not look like those are equal. Therefore, this is a false proportion. Now, it doesn't matter how many times you have to go through the simplification process, which is cross-multiplying to get it down to just 2 numbers, whole numbers, but you can go through it as many times as you need to. As long as you have one fraction equal another fraction, the procedure is cross-multiplication. Let's take a look at example 6. This time we have one fraction is the first fraction of the first ratio is x is to 3. It's x over 3. And the second one, 12, is to 9. Now, you know that you can always reduce an individual fraction. In other words, we look at that 12/9 and say, I could reduce that, divide both by 3. But let's don't this time, because I want to show you how to solve a proportion that has an unknown. This is the unknown variable x. We do the same thing. We cross-multiply. I'm going to say x times 9, and I would always write that 9x. You would too. We always put the variable second, is equal to 3 times 12. That's the other cross product. Well, that means that 9x is equal to 3 times 12 is 36. How do I solve this equation? Same way I've been doing it. I divide both sides by 9. That means that x will be equal to 36 divided by 9, or 4. So I've actually found a solution that makes that proportion true. If that number represented by x is 4 over 3, then it becomes a true proportion. Let's look at number 7. Same thing, we have an unknown, which is z, so let's cross-multiply to see if we can find the solution that makes this equation or this proportion true. I'm going to go ahead and do 12 times 16. Doesn't matter which side you do first. And then I'm going to do z times 10, or I would write that with the variable last, 10z. Now 12 times 16, I can't do that in my head, so I'm going to write it over here. And 2 times 6 is 12, carry your 1, 2, 3, put down my 0, and I say 1 times 6 and 1 times 1, and I add. I have 2, 9, 1. It looks like I've got 192. 192 is equal to 10z. Now, how do I solve for z? Well, I divide both sides by the coefficient, which is 10. Now, remember when you divide by 10, you really just have to move the decimal from right here one place to the left. So I don't have to do too much division here. I just know I moved my decimal point, and my answer is 19.2.